Alright, so welcome back to everyone. A very warm welcome to all the NEET aspirants, all the future doctors. So, guys, we are here again to discuss the physics, to continue the journey of our physics. Okay, so I hope our preparation is moving in the right direction, and we are watching each and every chapter daily. Okay, okay, so guys, now what we have done till the last session. So before that, let me introduce myself. My name is Dr.Uma Shankar and I am your physics educator. These are some brief credentials about me. Now, let's move to the point. Okay. So guys, in the last session, what we have done, last session में क्या बात हुआ था? So in the last session, what we have done, guys, in the last session, we have been speaking of, in the last session, what we did, so in the last session, what we did, so in the last session, we were talking about the kinematics, and in the last session, basically what we did, so we did one thing. So, sir, from the equation of displacement, okay, we reached the velocity, okay, and from the equation of velocity, we reached the acceleration. And how we did the journey? So we did differentiation. So we know that v is equal to dv ds by dt, and a is equal to dv by dt. So previously what we have done, previously we have understood the concepts of differentiation, and using those concepts, using those very concepts, we have covered this particular portion of kinematics, in which we learned to see that how we can go from displacement to velocity, or how we can go from velocity to acceleration. Okay, now if we want to make a reverse journey, okay, if we want to move in the reverse direction, that is, sir, if we want, if we are having the velocity, if we know the velocity, and if we want to get the displacement, or if we are having acceleration and we want to get the velocity, what should be our approach? So for that, you need the information about one more mathematical tool, that is your integration. That is your integration. Okay, now in this session what we are going to do, so in this session we will be talking about the concept of integration. So in this session I'll be taking you to the journey of integration. Okay, and I'll be just telling you only the integration that is required for a NEET aspirants to deal with the physics of NEET. Okay, so integration itself is like a ocean. Are you getting my point? So it is a so big a topic, and our friends who are trying to studying for JEE. Okay, they are studying this integration in a very great depth. But do we require that much? No, sir, absolutely not. We do not require that much. In just this session, I'll be giving you some information about integration, and that information you may use. That information you may use to, apply in the physics. Okay, and later in the journey of the physics, wherever we'll find some new information to be given to you, we'll do that. But in general, we must know something about the integration. So the first thing I want you to know and remember, that this is a reverse process of differentiation. Okay, so if you remember this very statement, that this is a reverse process of differentiation, by itself you will be able to do a lot of things. So integration is what? Sir, it is a reverse process. It is a reverse process of differentiation. Okay, it is a reverse process of differentiation. Remember that. Okay, remember that. So what is the need of it? First of all, in kinematics, as I said, so see, this thing we have done with the differentiation. Now from integration, let's suppose we are having the v, or we are having the a, that is our given information to us is about the velocity and acceleration, and from it we want to, from it we want to get, from it we want to get the displacement or velocity. So for that you have to go in the reverse direction. You have to go in the reverse direction. So that means you need to do integration. Okay, so when you do integrate the velocity, when you integrate the acceleration, you are going to get the displacement, and you are going to get the velocity from the acceleration, right? This is something what we have come to know. Now we understood. See, this is the sign of integration. So let me, before that, so let's suppose dy by dx. Okay, so sir, we know that this is the sign of differentiation. Dy by dx is the differentiation. So this is, sir, we know that it is the slope of the curve. Okay, dy by dx refers to the slope of the curve. Now, when you are talking about this integration, when you are talking about the integration, and we write, see, integration y dx. This is the symbol of integration. So, like how you read this, dy by dx. So, how do we read this? So, sir, we read this like, so differentiation of y with respect to x, right? This is how we read this now. Dy by dx, that is differentiating y with respect to x, right? Okay, and now we are having this integration y dx. So this is the sign of integration. So integration y dx, so basically this is how you read it. So when you are writing like this, so this is the sign of integration. You read it like integration, like d by dx is the differentiation. Same way, this is the integral sign. So this is the sign of integration. This is the sign of integration. And see what is happening here. So you are reading it like this: integration of y with respect to x. Similarly, this is the differentiation of y with respect to x. So it is the integration of y with respect to x. And now this dy by dx gives you the slope of the curve. So now what does this gives you? So integration y dx gives you the area under the curve. Are you getting my point, sir? This gives you the area under the curve. So basically, the differentiation, when you differentiate some variable with respect to other, it gives the slope of the curve in that diagram in y and x. And if you integrate the y with respect to x, this gives you the area under the curve. I hope it is fine to everyone, right? Now, remember one more thing that is will be used, okay, when we'll be coming to the thermal part. So integration y dx, so it is the area under the curve when projected on x-axis. This is also something of very important. So when you are writing integration y dx, so this is the area under the curve when you are projecting on the x-axis. This is the technical meaning of the integration. So why we do integration in the first place? Because we want to find the area under the curve, and it interprets a lot of things. Let me come to that. Now please understand this. Now let's understand this. Let's suppose we are having something like this. Okay, let's suppose this is x, this is y, this is x, this is y. Now, in this case, when it is x and it is y, so we are having like this. We are having a line like this, a straight line. So, what is the slope of this curve, sir? It is definitely constant. Okay, definitely constant. Now, please try to understand it. Sir, if I want to integrate, or if I want to, like, I want to get the area under this curve. So, why you want to get the area under this curve? I want to. I want to. है ना मेरा मन कर रहा है are you getting my point? So I want to have the area under this curve for any reason. So what could be the possible reason? So later on, when you see, when we move further, so the live students, welcome to the session, very good afternoon. So see, when you see some topics, like when we go into the thermal, you will see that the work done by the system is given by area under pressure volume diagram. How it is going to do so, we'll talk there. But at times, to calculate different things, we need to do that. Like area under force and displacement curve is work done. Okay, area under T and theta, that is turning moment or torque. Okay, okay, and the angle of rotation. Okay, okay, it is also the work done. So many times we are requiring we are supposed to find the area under the curve. Now, in this case, we can definitely find the area under the curve. So, how we can find the area under the curve? So, very easy it is. So, sir, it seems like a triangle. So, definitely, if we have this, let's suppose anything it could be. If we have this dimension, Okay, that means if I have the coordinate of this point, if this very curve is starting from here, definitely we can find the area of the curve because this is the known geometry. This is what? This is the known geometry. Now, in a similar way, in a similar manner, what can we do? In the similar manner, what can we do? So, sir, in the similar manner, so it's see, like there is a curve like this. Let's suppose we are having a curve like this, and when we are having a curve like this, basically what is going to happen here, what is going to happen here? So I want to find the area under this curve. So how can I find the area under this curve? So I can find the area under the curve this way, right? Very, very easy, sir. This seems to be a rectangle. So if we know the coordinates, if we know the dimension, definitely we can find the area under this. We can find the area under this. Now, why? Hello, hello, Shusai. Hello, welcome to the session. So as discussed, we were talking about the integration. Okay? इंटीग्रेशन के बारे में बात कर रहे हैं. We are talking about the integration, and in integration basically I was just telling you guys that see what happened till now, just giving you a brief overview what we have done till now. So see what we have done till now. So previously in the previous session you remember, so we moved from the displacement, we come to find the velocity. From velocity we found the acceleration, right? Right. Now, what if we are given with the velocity? That is the velocity we are knowing of something, and now we want to find this displacement. Or if we want to, if we are having the acceleration of something, we want to know is velocity. Now, in that way, we have to move in a reverse process, okay, of differentiation. So, what is the reverse process to differentiation? The reverse process to differentiation is what we call as the integration, right? Okay. Okay, so basically integration is the reverse of differentiation. And now we already have accompanied with dy by dx. So it is the slope of the curve we know already. And how we read it? So we read it like the differentiation of y with respect to x. Now this is the sign of the integration. Okay, and this is how you read it. So integration of y with respect to x. Okay, and mathematically, so as in the same manner like dy by dx gives the slope of the curve, integration y dx, it gives the area under the curve when you are projecting it on x-axis. So basically when you are integrating a function, you are finding the area under the curve when it is projected on the axis about which you are integrating. Like for example here integration y dx, so the area under the curve when projected on the x-axis, like here. Okay. Okay, so sir, the question may come in your mind, sir, why do we require to find the area? So see, there are many physical quantities which can be calculated easily by plotting the area under the curve. Are you getting my point? Okay. Okay, like for example, work done is equal to force into distance. So if distance is varying, okay, if the distance is varying, loosely it is force into distance. No? Okay, so though. So if this is varying, so you may require to find the area under the curve. When you go to the thermal side, you see PdV work. Do you see that? The work done in a closed system is equal to integration PdV, right? So why do we use that formula? Okay. Okay, so we are requiring to find the area under sum of the curve to understand the physical quantity. Now, in the case when, like for example, this is a straight line. Let's suppose y versus x curve is like this, so like this one. Okay. Okay, so if it is like this or if it is like this, there is no need of integration. Geometrically, we can very easily find the area under the curve because this is a known geometry. This is a triangle. This is also a known geometry. This is a rectangle, right? So obviously, we can find the area under these. So we do not integration. We do not need integration for this. Now, similar way, like in y versus x curve, when the line was straight. Now to find the slope, you need not to differentiate, but you could find it by the difference between 2 points. Do you agree to it? Yes, sir, definitely. So why at all we need the integration? Now you suppose we are having, let's suppose this is y, this is x. Now let's suppose we are having somewhat curve like this. Okay, we are having some curve. Let's suppose like this. Okay, we are having some curve like this. Now, if we want to find the area under this curve, if we want to find the area under this curve, so this is no known geometry, right? This is not a known geometry, right? Okay, this is not a known geometry. So if it is not a known geometry, So whenever you want to find the area in the curve which is not a known geometry, then you could pick up for the integration. This is the need of integration in physics. Are you getting my point? Because as I always say, my dear, that mathematics is just a tool to be used in physics. Okay. So integration finds its use in physics in finding the area of the curve which are not the known geometry. Understood? So sir, how can we find? How can we find? What is the integration? What is meaning of integration? So see what we do. Please understand this. So see, if I divide this area under this curve, so I can see the area under this curve. So if I divide this area under the curve into many infinite small strips, okay, and this is very small infinitely small strips. So such infinitely small strips, such infinitely small lengths or quantities are represented with the subscript d, because they are differential quantities. Okay, so this is dx. This is dx. Do you agree? Now, if I say this whole area under this curve is made up of such many strips, so do you agree with it? If I distribute, if I divide this particular area under the curve by such infinitely many strips, okay, okay, then adding, please understand this, then adding the areas of each of the strips will be giving you somewhat, the area under the curve. Do you agree to it or not? Do you agree to it or not? Okay. Okay, so sir, it must be like this, no? So see, if I say this is y, okay, so you would say the area of this strip is y dx, and when we are summing up many such strips, areas, it will be giving you the area under the curve. So sir, you must say, sir, we must be using this sign, no? So we are not using this sign. Why we are not using this sign? Sir, we are not using this sign because if you see the strip, so strip basically, so if you see it here, so if you see it minutely, so in each of the strips, this is the very basic thing I'm telling you. This is the area. See this, which is I'm darking now. Do you feel that this area will be left from counting from here? Do you agree to it? So that is why we are using this mathematical tool integration instead of summation. That is why. So this is not going to be work here, but this is going to work here, and we'll write y dx. So integrating y dx, and we can define in cases the lower to upper limit of this integration. Understood, my dear? Understood the need of integration. The need of integration. So basically, let me come to the point. So see, there is a curve. Okay, just try to, because see, we do not need to go into this much depth, no? Okay, let's suppose we are having a curve somewhat like this. Okay, now if you want to, because lately we will be having to, interpret what is given in the curve. Okay, that is a very important cases in the physics. So the slope of this curve will be given by, if you want to find the slope, if you want to see the slope, you can go by the differentiation. And if you want to see the area under the curve, which area, sir? Which is projected on the x-axis, the area which is projected, on the x-axis. So this area is going to be integrating this y function. So if y is a function of x, okay, so if y is a function of x, then only you differentiate, and similarly then only you integrate. So this integration is going to give you the area under the curve. But remember, this area will be given when you are projecting it on the x-axis. Understood? Okay. Is this clear up to this point? Yes or no? Please give me a yes so that we can proceed. Now, sir, what we should do now? So, see, we have seen some basic formula of differentiation. Now, similar way, we are going to see some basic formulas of integration, so that in your journey of physics, you will never get hampered or never get obstructed by from the understanding of integration. And then we will be applying this to fundamentals, some basic problems of kinematics we'll try to do in this session, otherwise we'll do in the next session. and from there you will be able to get the need of it. Okay, so let's move forward. So let me come to the point. So there are some formulas that you need to memorize here, or you need to know. She said basically I am from Lucknow, but I live in Roorkee, Indian Institute of Technology, Roorkee. Okay, so right now my location is Roorkee, though I belong to Lucknow, Uttar Pradesh. भैया हूँ मैं भैया. Yeah. Chilling. So basically in the same line we are going to understand some formulas. So see the first formula in the differentiation was this. Now here it is also like this. So n x n plus 1, sorry, x n plus 1 upon n plus 1. Understood, Bida? Understood? Okay, this is the formula. And remember one very important thing. So that is plus c. Okay, what is the c, sir? What is the c? So see, these kind of integration, I'll write the formula again, don't worry. Let's try to understand one thing. So this is integration x to the power n dx. So now when I integrate in, this is the formula that you must remember. And you must also take note of this, that whenever you are integrating like this, there is something called as the constant of integration, that is c, will come into picture. Okay, this is c, the constant of integration. Where is your friend today? Constant of integration. So c is what? C is your constant of integration. Now remember just one thing. Okay, see, when you are integrating like this, that is you are integrating without limits. So that means it is an indefinite integration. Indefinite integral, this is called, or indefinite integration, this process is called. Now in this case of indefinite integral, there will be constant of integration. Now if at all you are integrating the same function within some limits. Let's suppose you are integrating in some numbers or some limit. Let's suppose you are integrating between 2 and 7. Yeah, she said you can do that. Okay, meanwhile you can concentrate here also. So if we are integrating within the limit, this is how, when you are integrating with limits shows. So this is what we call as the definite integral. So definite integral, where you are integrating when you are having no limits to some curve. Now in this case, how you are going to do it? See, simply the formula remains the same, but there will be no constant of integration, and you will write it like this, that 2 and 7. This is called as the lower limit. This is called as the upper limit. Okay, so there will be no constant of integration in definite integral. That is when you are integrating within some limits, some defined limits. So now in this case, what is going to happen? So n plus 1 is constant. It will be outside only. Now x n plus 1. So you are going to put the value of 7 in the place of x. Okay, then you will write minus 2 n plus 1. This is how you put the limit. Lower limit will come first, minus the upper limit will come first, minus the lower limit. Okay, is it fine? Very, very simple. How to put limits into the integral, right? Wonderful. Wonderful. So constant of integration is very important. Don't forget about the constant of integration, otherwise you are going to make the mistake in the question. Because see, we are given some information. We may be given some information in the question, using which we may calculate the constant of integration. Are you getting my point? Right? Wonderful. Now moving ahead, now please see, this is the first formula. Let me give you again. So xn dx is equal to xn plus 1 upon n plus 1 plus c. Now, one more very important information here is, so see, this is when you are integrating a function. When you are integrating a function, so whatever you are getting after integrating a function, if you differentiate that result, you will getting the function again. Are you getting my point? See, integration, Bima. Very good afternoon. Hello, welcome to the session. So, my dear, we are talking about the integration. Okay, integration के बारे में बात कर रहे हैं, and why हम integration के बारे में एक बार आपको भी रिव्यू दे देता हूँ. So देखो, पीछे हमने differentiation किया था, differentiation का use देखा था. We have seen the differentiation and we have seen the uses of the differentiation. What were the uses of the differentiation? Sir, if you want to move from displacement to velocity, that is when we want to find the velocity from the displacement, or we want to find the acceleration from the velocity. Okay, okay, we do the differentiation. Now if we want displacement from the velocity, or if we want velocity from the acceleration, we need to integrate. So integration is basically a reverse process of differentiation, and this is how the sign of integration look like this like this. Okay, this is the sign of integration. So basically, quickly I'm telling you, so integration is the area under the curve. Okay, it is the area under the curve. Likewise, the differentiation is the slope under the curve. Now, likewise, the integration is the area under the curve. Now we are seeing some formula. So the first formula is integration x to the power n dx is equal to xn plus 1 upon n plus 1. Plus c. This is the most used formula of integration or differentiation in the case of physics, that questions that are coming in the NEET examination. Are you getting my point? So integration x to the power n dx is equal to x n plus 1 upon n plus 1 plus c. Okay, so whenever we are integrating without limits, then there will be a constant of integration which could be found by using some information given in the question. That is also we are going to see. Okay, but first of all, now as I said, integration is a reverse process to differentiation. Okay, okay, so integration is sort of opposite to differentiation. So now if I differentiate this whole thing, so what is going to happen? It will become x to the power n. Okay, how? Sir, integration differentiation will cancel each other out. Okay, now if you are because they are opposite to each other now, so if you differentiate this whole thing, this integration sign and differentiation, they will cancel themselves. Okay, so when you are writing d by dx and integration of dx, so if they both are multiplied, it will become 1. Are you getting my point? Are you getting my point? Because they are reciprocal, reverse to each other. Now this will become x to the power n. Now when you differentiate this very equation, so what will happen? So if you differentiate this thing, let's suppose if we are differentiating, this is a a way to remember the formula. If you are making any mistake, then also you will be, if you remember, if you know how to differentiate, you can see this way also. So now what is going to be the differentiation to it? So sir, we know xn plus 1, so it will become n plus 1. N plus 1 is there in the denominator, and xn plus 1 minus 1, so it will become xn. The differentiation of c will be becoming 0 because it is a constant. So we are getting x to the power n. Okay, so when we have integrated x to the power n, we get this result. Okay, now if we differentiate this result, we are going to get the function again. Is it fine? That is why integration is a reciprocal reverse to the differentiation. Okay, I hope it is fine to everyone. Yeah. Now let me write the formulas again. So integration, the first formula, integration x to the power n dx is equal to x n plus 1 upon n plus 1 plus c. Okay. Okay. Now if I write integration of 1 dx, so how it could be? Yeah, how it could be? So 1 dx, that is x to the power 0. So x to the power 0 plus 1, that is 1, upon 0 plus 1, that is 1, plus c. Okay, plus c. So integration of 1 becomes x. Remember, the differentiation of x becomes 1. Right? Okay. Okay. Now if I write integration of x dx, so what it will become? Sir, x to the power 1. So n plus 1, that is x square, upon n plus 1, that is square, plus c. Right? Do you agree? Definitely, sir. Now if I ask you what is integration of x to the root x dx, what you are going to tell me? What will be the integration of root x dx? Can you answer me that? Can you answer me that? Anyone? Very, very simple. Yeah, constant. This is the C, na? So when you differentiate the constant, it will become 0. You are saying that the constant disappeared in differentiating is the C. Yes, it disappeared when you differentiate this. Okay. Any constant when differentiated, it becomes zero. Na? We have seen in the mathematical tools part one. So what I'm trying to tell you just it is that sir, when you integrate a function, you get some result. If you differentiate that result, you are going to get the function again, right? So what it is going to be is integration x to the power 1 by 2 dx. Okay, so we can compare it from here. So it will become x to the power n plus 1. 1 by 2 plus 1, it will become 3 by 2 upon n plus 1, that is 3 by 2 plus c. Okay, okay, so it will become 2 by 3 x to the power 3 by 2 plus c. Understood? Yeah, yeah. Okay, very simple. Now let's move to some more formulas. Very simple. I'll keep it very quick. So integration of 1 by x dx is equal to log base e x plus c. Sir, how come? Remember when you differentiate log x, what was the formula? Sir, it is 1 by x. It is 1 by x. So if you differentiate it, if you integrate it, so it will become 1 by x of log x plus c. Okay. Now similarly, if we write integration of cos x dx, integration of cos x dx, so it will become how much? It will become, yeah, don't miss plus c. Okay, that is very important. Sin x plus c. Sir, how come, sir? So if you differentiate sin x, you get cos x, right? So you are going to write cos x, integration cos x is equal to sin x plus c. Now 6 will be integration of sin x. So it will become minus cos x plus c. Okay. Okay, so see in NEET, though you most of the time you are going to see this x to the power n thing. Okay, but just having some factor of safety that what if they are asking, they ask you some different function. In that, for that case also we must know some integration. Are you getting my point? Okay, we have to be safer now. Okay, okay, we just by knowing, so already you know these formulas of differentiation. Okay, so it is not a big deal, right? Okay. So how come it is minus cos x? So if you remember, d by dx of cos x is equal to minus of sin x. That is d by dx of minus cos x is equal to sin x. So when you reverse the process, you are going to get the reverse result, right? Now what is going to be integration of sec square x dx? So you remember d by dx of tan x is sec square x. So it is going to be tan x plus c, isn't it? It is going to be tan x plus c. Now, similarly, if you know, now see what I'm trying to tell you, if you know the formulas of differentiation, the same way you can use it in integration also. So, for example, cos x square x. So, d by dx of cot x was minus cos x square x. So, the integration of cos x square x is equal to minus of cot x plus c. Okay. Okay. Now, what was the differentiation of sec x? Yeah, thigh. So what is the differentiation? So I'll just move to the next page. So what is the differentiation of sec x? The differentiation of sec x was sec x tan x. Okay, so if you integrate sec x tan x, you are going to see the sec x plus c, right? Now similarly, what was the integration? What was the differentiation of cosec x? So it was cosec x minus cosec x cot x dx. So if you relate now after this session, if you see the notes of, and you are making the notes, right? You are making all the notes now, right? Okay. So it will become minus of, sorry, cosec x. Just one moment. Cosec x plus c, right? Minus of cosec x plus c, isn't it? Now moving further, yeah, this is 11. So now do you remember? Uh, so now similarly, I'm writing some more formula. So this is log of, so this in is log base e, right? When we write this in kind of a thing, that is your log base e. Okay. Similarly, if you write this, so these are frequently used formulas. Cot x dx, it will become, log of sin x, plus c, log of sin x plus c. Okay. Okay. So these are the basic formula. Now similarly, let me write for all I have to complete now. So second, so these are rarely used, tan x, cot x, but just for your information, so that if it is asked from you, you will be able to answer sec x plus tan x plus c, and what is left? So cosec x is left now. So integration of cosec x dx, okay, integration of cosec x dx, log of it will become log of, so actually it is minus log of cosec x plus cot x plus c. Okay, okay, understood, beta? Okay. So see, remember, remember, guys, one thing that's remember one thing, that these formulas might not be used like from these. So mostly in the NEET you are going to see these basics one, sin x, cos x, and most used one is x to the power n. But see, my point is that see, you at least can do till this, till 10. Okay, why sir at least we can do? Because these formulas you have seen in the case of differentiation also. Okay, so it's just the reverse to it. Clear? Clear? Okay, now let's talk something about the algebra of integration. So like there was the algebra of differentiation. Similarly, we have the algebra of integration. We have the algebra of integration. So see what is going to happen. So let's suppose y is equal to x square plus 1 upon x. Okay, so now we want to integrate this. So integration of y dx. So this function is in terms of x. This function is in terms of x. So I can only integrate it with respect to x. Okay, so when I am integrating it, when I am integrating it, when I am integrating it with respect to x, what is going to happen? When I am integrating it with respect to x, what is going to happen? So, sir, I can take this integration sign within the each terms of it. So, like same to the differentiation. So, I'll write it like this: integration x squared dx plus integration of 1 by x dx. So, you just take your integration to each and every term on the right hand side. Very, very easy. So, sir, this will become integration of y dx. Now, when we are integrating, it will become x cubed by 3 plus log x, okay, plus c. Don't forget this c, my dear. C is very, very important. C is very important. You are going to see the importance of C very soon. Right? Now, similarly, if I say so integration e to the power, I didn't write integration e to the power x. Just adding one more formula to it. Let's suppose 8.1. So integration e to the power x dx is equal to e to the power x. Remember, okay? Because when we differentiate e to the power x, we get e to the power x only, na? So similarly, when we integrate e to the power x, we are going to get e to the power x only. Understood? Understood? So let's do one more. So let's suppose we are having y is equal to e to the power x plus sine x plus root x. Please write. Please write. I'm very sure we can do it. No problem at all. Please try to do it. I'm very sure we can do it if we try to. So how we got to do it? So when we integrate it, So see, right away I can take the sign of integration within the function. So integrating e to the power x, it will become e to the power x. Then integration of sin x, it will become minus cos x, plus integration of x to the power 1 by 2, it will become x to the power 1 by 2 plus 1 upon 1 by 2 plus 1, right? So very, very simple, you will be able to deal with it. Now, sir, if we have y is equal to x sin x, if we are having y is equal to x sin x, now how we can do that? How we can do that? How we can do that? Sir, if I want to integrate this with respect to x, okay, so how we can do that? So for this, we must know one rule, that is integration of uv dx. So if you remember, in differentiation also we learned the uv method, right? We learned the uv method, okay, uv rule, very good. So how we can write the uv rule? So see, u, then you are going to integrate the v minus c, how you are going to do it. So now you are going to write this u, you are going to differentiate this u within the sign of integration, and you are going to integrate this v again here, okay, and then you are putting this whole bracket, and then dx. Understood? Very, very simple. Okay, shall I write it again? See, simply when you are having u v dx, see, you are taking this u. Sir, which one is u, which one is v? So for that, there is a rule I am going to tell you. So this u, and now the, see, first thing you have to select which one is u, which one is v. It basically helps you the solving the question quickly. So u is the, now integration v dx. Now there is a sign of minus, then you are writing integration. Yeah, she said. Works, no problem. So we are having this u, have a good day, my dear. So u is there, then we are getting integration v dx. Now we are writing like this. So whatever you are left here, so you are going to differentiate it here. So du by dx it will become, okay. Then you are writing this integration again. So you are writing this integration thing again, v dx. Now whatever you are getting in this, you are going to integrate it again with respect to x. So this is how you can do. This is how you can do the UV integration. Okay, UV integration. Now here, one thing is important, that's how we are going to select which one is U and which one is V. So out of the two functions, one would be U and one would be V. Okay, so how you can select this V? Now to select U, okay, to select U, so out of the two functions, which one is going to be U? You may use a rule, that is ILATE. Okay, what we call it, sir? We call it ILATE. ILATE. Remember, this is a very important rule. This helps you to integrate quickly. This helps you to integrate with less labor. Otherwise, the labor will be very much. So ILATE. So I is inverse function. So what is inverse function? Like sine inverse, cos inverse. Then L is the log function. A is the algebraic function. A is the algebraic function. T is the trigonometric function. And E is the exponential function. E is what? It is the exponential function. So basically, this is the priority in which you must select the U. Okay, like for example, in some problem you are having u dot v. So what you can do? You have to select one as u. You have to select other as v. Okay. So you can select the u in this priority. If there is an inverse function, you will give it priority before log, algebraic, trigonometric, and exponential function. If there is a log function, you will give priority to it over algebraic, trigonometric, exponential, and in the same way you can go for algebraic, trigonometric, exponential. Remember, exponential function is least it is in least priority to be selected as u. Why so? Because see, when you differentiate exponential function, it is not going to get changed, right? Okay. So now, for example, if we go to it, okay, so you are going to, which one you will be considering as u and which one you will be considering as v? So sir, x is an algebraic function and sin x is a trigonometric function. So we have ILATE. ILATE. So algebraic function comes before the trigonometric function. So here you must select the algebraic function as u, and the remaining function obviously it will become v. So it is going to be u is going to be x, v is going to be sine x. So when you are writing integration y dx, that is you are writing integration x sine x dx. Now in this case, what you got to do? So u is x, so you will be writing u here. Then you will be integrating this sine x. So when you integrate this sine x, you are going to get minus cos x minus integration. Now you see you are going to differentiate this u. So when you differentiate this x, it will become 1. And then again, when you differentiate this sine x, it will become minus of cos of x dx. Now simply you can write minus x cos x, and this is going to be minus minus plus integration of cos x, it is going to be sin x. And don't you forget about the c. Don't you forget about the c. I hope it is fine to everyone. Okay. Okay, so what is the integration? It is going to become minus x cos x plus sin x plus c. I hope it is fine to everyone. Now similarly, if I ask you to integrate, let's suppose x e to the power x dx, can you integrate it for me? Can you integrate it for me? Yeah. What do you say? Can you have it integrated for me? Can you integrate it for me? Yes, sir. So here we can see that your function is a product of two other functions, that is x and e to the power x. So here you have to select one u, here you have to select one v. So u is your x, how sir? How sir? Sir, ILATE. So x is algebraic function. X is algebraic function. So you can take x, you can take here, u as x and v as e to the power x, So how we can do it? So now so leaving u first, then integrating the v minus differentiating the u and integrating the v again. Okay, so it will become x e to the power x minus e to the power x. So it will become e to the power x minus 1, e to the power x minus 1, right? Okay, okay, plus c. Don't forget about this c thing, right? Don't forget about this c thing, right? Okay, okay. Now similarly, if we want to, now this is very interesting. Now let's try to integrate this one, log base e x dx. Now if I want to integrate this, how we can integrate this one? Can you try this one? How we got to integrate this? Integration of log e to the log ex, okay, log base ex dx. Can you try that? Can you try that? Let's see if we can do. Any live students may want to answer this. You are most welcome. So how we can do it? This is important, and this you may consider as a formula as well. So now what we can write, how we can write it. So can I write it like this? Sir, integration of 1 log base e x dx. Can we write it like this? Can we write it like this? Yes, so we can write it like this. Now please understand this. So now again we have ILATE. Okay, ILATE. So one is your algebraic function because we can write it as x is equal to 0. So one is algebraic and this is a logarithmic function. Now in this case, which should be u, which should be v? So sir, u should be logarithmic function because we must give preference to the logarithmic function over the algebraic function, trigonometric function and exponential function. So u is going to be log base ex, and now here v is going to be 1. So how we are going to do it? So sir, when we are going to integrate it, we are going to integrate this thing, so it will become 1 log ex, okay, dx. So see, you are leaving the u, integrating the v. So when you integrate 1, it will become x minus, you are differentiating the u, you are differentiating the u. Okay, so the differentiation of log base ex is going to be 1 by x, and then you are integrating this v, that is becoming x here. Okay, so it will become x log x log base ex minus integration of 1 dx is equal to x only. Integration of this 1 is going to become x only. So it is going to be x log ex minus x, and don't forget about this c because this is indefinite integral. We are not putting the limits to it. So this is the thing which is very, very important, that you always and always remember that whenever we are integrating without the limits, there will be there will be a constant of integration to it. Okay. 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 Okay, sir. Wonderful. Okay, so this rule also we have seen. Okay. So in NEET examination, do we require this much? So see, as I told you, so there are very simple questions asked in the NEET examination most of the time, but it is also the fact that out of blue, there were questions in which this much integration were used in the previous year NEET examinations as well. Okay. Okay, so I recommend this is just a matter of 1 hour. There's the basic simple integration. Many say, "So this complicated integration, this is not complicated. Complicated integration, just ask your friend who is preparing for IT JEE. Okay, integration and differentiation is mostly there in the mathematics. Okay, okay, so it is very, very good. I'm just telling you the basics only. Don't get afraid. Just very simple rules, simple thing. Okay, now there is one more thing to it. Okay, let's suppose we are to integrate integration sine x, we know, but what if it is integration sine ax dx? Integration of sine ax dx. Now simply how we can do it? So sir, how it is differ from the standard expression or the standard formula? So how it is different from the standard formula? So sir, we learned the integration of sine x. Okay. Okay, so you have to use that only. See how I am going to do this. So what is the integration of sine x? Sir, it is minus cos x, but it is ax. Okay, so it will become minus cos ax. Now in the differentiation, you are going to write a. So from where this a came up? So when you are integrating this, so this thing you are differentiating. So you have differentiated this thing, whatever is written there, and whatever is there when you differentiate it, write it to the denominator of your result. Understood? Write it to the denominator of your result. So integration sine ax dx will become minus cos ax upon the differentiation of ax in the denominator to it. Okay. Okay. Understood, sir? Now similarly, if we want to integrate cos ax, what it will become? What it is going to become? Can you please answer me? Can you please answer me? Oh, don't forget about the C, na? Let's see. right? So what it is going to become? Sine cos ax. If I write cos ax, so what it is going to become? Can you answer me? Can you answer me? So of course, sir, cos ax it will become, sir, sine ax, because integration of cos is sine, and then we are going to differentiate the function, which is different from what we have learned in the standard way. So ax, when it is differentiated, it will become a, that will become c. Okay, that will become c. Now similarly, if you want to integrate e to the power, let's suppose 2x dx. So sir, what is the integration of ex? It is ex, so you write that. And this thing, which is extra, which is other than what you have learned in the standard formula, you are going to differentiate it to the denominator. So 2x differentiated, it will become 2 and it will become c, right? It will become c. Understood? Now, if I ask you to find the integration of cos x square plus 1 dx, what is going to be the integration to it? Can you please tell me what is going to be the integration to it? Can you try to solve it? Can you try to solve it? What is going to be the integration to it? Anyone? Any of the live students? In the same way you have to do. In the same way you have to do. So the very simple, sir. We are going to write it like, so integration of cos is sine. So we are going to integrate in a normal way. Then which is not the part of the formula. So you are going to differentiate it in the denominator. So it will become 2x plus c. Now if you want to integrate, let's suppose sine x cube plus e to the power x dx. Now how you are going to integrate this thing? How you are going to integrate this thing? How you are going to integrate this thing. So very simply again, sir, we are going to use the same concept. So integration of sine x is equal to minus of cos x, but this is not the x. So we are going to differentiate it. It will become 3x square plus e to the power x plus c. Understood? Understood? Okay. So these are some basic, very basic rules of integration, very basic formulas to integration. Now, one last thing in the integration I want to tell you. One last thing in the integration I want to tell you is the integration by substitution. Just a small, just one or two question. Okay. So sometimes if the integral is little bit complicated, so you have to do the substitution. You have to do substitution. So how we do it? So let's suppose we have to integrate x upon 1 plus x square dx. Now, sir, how we are going to integrate, sir? How we are going to integrate, sir? So by UV method and by any other method, it is going to be complicated. Okay, though it can be solvable by that also, but if you want to further simplify it, you may know this concept also. So see, in substitution, basically we are substituting something to some other variable, so that we simplify the question. So here if I write 1 plus x square is equal to t, okay, so I am substituting this denominator by t. So see, simply I tell you, for NEET level, see, if you at all is stuck in some integration question or kinematic question where you are requiring to do some integration, so do just one thing, just check by substitution, and 99% of the cases the substitution will be the denominator. Okay, now sir, why we are no problem, Shivesh. No problem, Shivesh. But although we are just, completing the session, so you may watch the recording. See, in this session, what we have done, in this session, we likewise, in the mathematical tool part one, we have studied about this, differentiation. Now, same way we are seeing here integration in the basic level. And in the next session, we are going to apply the concept of integration. So when we are meeting tomorrow, before that, you just watch this recording so you know how to do some basic integration, what is the meaning of it. Okay, because in the next session we are going to use this integration to understand some problems. Okay, okay, work for you. Okay, so don't worry, nothing to worry about. So just I was concluding, so this last concept I wanted to tell you guys. So see, integration by substitution. So what you have done, sir? So we have considered this 1 plus x square as t. Now by doing so, what happens? So if we differentiate this on the both side, it will become 2x dx as dt. 2x dx as dt. Now by doing so, see what is our benefit? What benefit we come to get? So now we can write it like this. So x dx will become dt by 2. No? See, x dx. See, so normally we do this substitution so that some of the points will be reduced and your differentiation integration simplifies. So x dx is replaced by dt, and now x dx replaced by dt by 2. So I'll write 2 here, and this 1 plus x square whole thing become t. Okay. Now it is very simple to integrate now. So we can take the constant outside. Now integrating 1 by t, it will become log t, obviously base e plus c. Okay, always remember there will be a constant of integration. So now we can put it back. We can put it back. We can put it this the value of t. So it will become half log base e 1 plus x square plus c. So just by substituting, you got a very easy way to solve this question, right? Right? Okay. Okay. Likewise, if you want to do one question, let us try one. So let's suppose we need to integrate this function sin x minus cos x, okay, upon sin x plus cos x dx. Okay. So this looks very complicated. Okay. Okay. So, sir, one way we can do, sir, we can, you know, we can see it may be solved like that also. So what we can do, we can bifurcate it in two different terms. Then we can use UV method. It is going to be very, very complicated, right? Better when you see a question, better try by substitution. Okay. Whenever you think that the question is getting somewhat complicated, just try by the substitution. So, sir, here, and as I said, most of the cases, the substitution is going to be a denominator. So see here, if I write, so I have given you the hint. Now please try it one. Let's try it one. Let's see if we can try it. Just try it once. Just give it a try. So how, sir, how we can do it? Now please understand it. So integration sin x minus cos x dx upon sin x plus cos x. So those who are watching recording, please attempt it by your own one. So now see, I have given, I can substitute the denominator by some new variable. Let's suppose that is t. So if I differentiate this, this will become cos x, this will become minus sin x, and there will be a thing coming dx. Okay. So when you are randomly differentiating, okay, randomly, so this is a function of x, so you get a dx here and you get a dt here. Okay. Okay. So now from here you see it's a sin x minus cos x dx. So can I write this equation like this? Okay, if I do the substitution, so see cos x minus sin x, so sin x minus cos x will become minus of dt, and sin x plus cos x is t. Sin x plus cos x is equal to t. So we'll be getting minus log of t plus c, minus log of t plus c. So you can replace the value. So you will be getting minus log base e. T is sin x plus cos x plus c. Plus C. Understood, my dear? Understood, my dear? So basically, these are the basic ways. These were the basic ways to do the integration. So guys, we have seen in this section. So I'll stopping this session from here. No more concepts for today. So see, in the next session, what we are going to do. So if you understand the journey we have taken up in the kinematics. So what is the journey, sir, we have taken up? So we started with understanding of distance, displacement, then we moved to the average speed, average velocity. Then afterwards, we required to understand the instantaneous velocity. So for that, we required some information of one of the popular mathematical tool, that is the differentiation. So we did one class there. on the differentiation, and we learned the concept of differentiation. Afterwards, we understood the concept of instantaneous velocity. Okay, instantaneous velocity. Right. Then we came up with the integration. Then we came up with the integration. Okay. Why we required integration? Because after doing differentiation, we knew that how from the displacement we can find the velocity, how from the velocity we can find the acceleration. Now, after learning the integration, in the next session, what we are going to learn? So, from velocity, how we can get displacement, from acceleration, how we can get velocity, and what else we can do from this very concept that we have learned in this session. Okay, so guys, please come in the next session as well. Please watch the next session as well. Very soon we are going to complete this kinematics. Okay. So after the next session, I'll be taking up vectors also together. Okay. So we know in NCRT 11 we have two topics of two chapters broadly of kinematics. One is motion in a straight line, motion in a plane. So motion in a straight line, all these things comes under the motion in a straight line. Now with the start of vector, motion in a plane will also be started. So we'll be taking up two topics at once. Okay. Okay. I hope it is fine to everyone. Right. Right. So guys, I'll keep it to this session. Keep it to this point in this session. I hope you guys have enjoyed the session. You have learned from it. So please do subscribe the channel. Please share it with your more friends so that they can also come live. They can watch these recorded videos if at all you are watching the recordings. Okay. Okay. So with this request, thank you very much. Have a good day, and we'll see you in the next session.